So today what we're going to be covering basically is the products, ESS overview, and the GX devices, and the new ones that's available, and battery compatibility. First up, we've got the inverter chargers. So on Victron Energy, they've got the Multiplus and Quattro range of inverters. The Multiplus and Multiplus II are the standard single output inverters that they've got available, and single input or grid source meaning, and then they've got the Quattro range, which has got the 2 AC inputs and then the 2 AC outputs available for you. As well as now, recently we've released the Multi-RS with a 450-100 MPPT. So these are high frequency inverters. They don't have the transformer built in on the input or output. They are a hybrid inverter. They've got a 6 kilowatt, or say 6 kilowatt MPPT built in with a 6 kilowatt inverter output, as well as a 6 kilowatt AC charger built in. These units can operate in 3-phase already. They can't be parallel as of yet. That will be available by about the beginning of next year, where we can 3-phase and parallel the multi-RS inverters. And then, yeah, so they've got 2 MPPT trackers and very lightweight, efficient inverters. So they're the new range that Victron has brought out to try and compete with the other high frequency hybrid inverters in the market. So pricing on these is quite good, and availability on these is also good in South Africa. On the Multiplus II, that's the inverters that's got the NRS 097 compliance. So those are the ones that's required to be installed in this city of Cape Town. They range from 3 kVA up until 15 kVA now. The 8, 10 and 15 kVAs got released this year, and then the NRS approval, or their NRS certification also got approved about 1 month ago, and they're going to be loaded onto the City of Cape Town's list within this month.
And these already?
It's already on the list.
These are on the list.
Correct. Yeah, so it's already on the list at the City of Cape Town, so you can install any of the Multiplus IIs up until 15 kVA. On the bigger units, they can't be paralleled yet as well, the 8, 10 and 15 kVA Multiplus II inverters. They're busy working on firmware and just testing all that before they're going to release the correct firmware that allows it to be paralleled for multiple units. Stock availability on the 8, 10 and 15 kVA has also been increased in South Africa, so they're quite available. The EasySolar II GX, so that's the Multiplus II inverter with a built-in MPPT and a small GX device built in. So the GX is for the online monitoring, and then it's got a 250-70 MPPT on the 3 kVA inverter and a 250-100 MPPT on the 5 kVA. Yes.
So this is basically the same as the RS?
No, so this one is based on the Multiplus II, so it's got the transformer built in with the low frequency topology, and then just the 250-100 MPPT built in. So the Multi-RS has got a 450-100 built in with the 2 trackers. So this one will have 1 tracker, and then it's also got the GX device built in on the EasySolar. So these units there's also quite a lot of stock available, but they're not as popular in South Africa for some reason. So on the inverter charger range, Victron has got the Multiplus starting from 500 VA, so it's a small unit. They can't, or they can only be set up in 3-phase. They can't be parallel to anything. So those small units from 500 to 1600 VA can only be set up in 3-phase, but they can't be paralleled. But they're nice and compact inverter charger units, also with the transformer built in. And then the standard Multiplus range, that's from 3,000 up until 15,000 or 5,000, and the Quattros from 8,000 up until 15,000 on the older units. And then the Multiplus.
Added to the Victron list as well.
So the Quattro 2s, Victron is also releasing. They will eventually be added onto the list once they've got the approval. But the older Quattros and Multiplus units have to be installed with the Zeal contactor set. So that's the approved anti-islanding kit that Victron supplies. So that's on the COCT list. So then with that you can use any old Multiplus inverters. The Multiplus II inverters just has the dual contact built in for the anti-islanding. So for that you don't require any anti-islanding device separate. And then we've got the new MPPTs also released. That's the 450-100 and the 450-200. The 450-100 has got 2 MPPT trackers, and the 450-200 has got 4 MPPT trackers built in. So you can have nice different string arrangements and orientations on the panels on the 450-200. It's got a maximum charging capability of about 11 kilowatts to the battery on 48 volts. So you can add strings from 3 panels up until 8 panels in series on these units. Depending on the panel, some can take 10. There's a nice high voltage MPPTs, very high efficiency on the MPPTs. And yeah, so they've got active cooling. They're not like the old MPPTs which have got natural cooling. They've got fans built in, so they have to be serviced as well on the MPPTs. And it's got an isolator switch built in on the unit, and PV connections. No, these ones don't, sorry, for the PV connections. The Multi-RS has the PV connections, and the MPPTs just has normal screw terminal connections for your PV. One thing to note is if you're installing them in a very high moisture area, it is recommended to put they put that petroleum jelly or any just anti-flashing material or terminal paste onto the PV terminals. Because of the installations in high humidity, it has caused flashover on the terminals on the PV on high voltages. So the Oaks just puts in the petroleum jelly over the terminals. But yeah, if you've got it properly connected and stripped, chances aren't that high, but yeah, in very high humidity areas, it is a chance for that. But that's above 90%, I would say. So just maybe install it in an enclosed area, not something that's open to the outside air here by the coast. So it's got PV isolation resistance monitoring as well, and you program it with Bluetooth from the Victron connector. These units communicate on CAN, so you can add up to 25 units on a string on one installation. Or if you also want, and you've only got one unit, it's also got a VE direct port, a single one, if you want to communicate via VE direct. But via the VE direct, you don't have the ability to change the settings remotely via the server. Then Victron has got the extensive range of MPPTs, starting from 10 amps up until 200 amps, now recently released. The smaller units are the 75 volts, the 10 amp MPPTs. So Victron's naming scheme works that the first number on the MPPT is the maximum PV input voltage, and the second number is the DC charging amps to the battery. So 75 volt, 10 being a 75 volt PV input maximum, 10 amp battery charging. So 10 amp at 12 volts or 10 amp at 24 volts. So if you've got a 12 volt system, you're going to be limited to a 120 watt panel. But if you've got a 24 volt system, you can run a 240 watt panel on the same charger. So the same going for the 115 up to 30, the 150, 35 up to 100, and the 250 from 70 up to 100. So that's just the maximum input voltage ranging from 150 to 250, and the latest units 450 volts on the PV side. On the units, they've got the older ones which don't have the VE-CAN capability, so that's also marked on the part number. If the unit has VE-CAN in the part number, then it's got the capability to communicate over the parallel bus of VE-CAN. But if it's the older, just standard Blue Smart or SmartSolar MPPT, then you're going to have to connect it with the V-direct communication. And on certain GX devices, you've got a limited amount of ports for that as well. So do take note when you're building the systems on these older MPPTs.
Sorry, just a question of clarity. So is it only the RS that has got the multiple tracking on the MPPTs?
Yes.
And not the others?
Yes. So only the new SmartSolar RS MPPTs have got the dual or quadruple trackers built in. So those are the newer units. They also the bigger units, so they almost have this form factor with the fans for cooling built in. So the 450-100 has got 2 trackers, and the 450-200 has got 4 trackers. Now on ESS systems, so that's the majority of the systems that gets installed in South Africa. ESS is an energy storage system that's basically utilizing your PV to a maximum, and whatever PV you don't use during the day, you store at night, or you store in your battery for use at night. So on a typical grid-tied PV system or typical sunshine day, you've got your loads which fluctuate during the day and your solar or sun capability, which peaks or starts low in the morning and peaks midday and then comes down again in the afternoon. So on a typical system or grid-tied system, you've got your loads which you draw at night, and during the day your excess PV gets fed into the grid or limited, and your loads are just sitting at your standard loads which you always run. You haven't optimized the loads to utilize the PV, so you're wasting quite a bit of PV power, and then at night again you're drawing power from the grid. So this is just a standard grid-tied setup. Now if we add storage to a solar system, what we can achieve is have our excess PV feed our batteries first, or charge our batteries up, and then at night we can take that excess PV from the battery again to feed our loads. So depending on the battery size that you design in your system, you can almost run completely optimized with your solar system if you've got enough PV. So you can achieve that majority of your PV excess power goes to your battery bank, which is sufficiently sized to take all that PV, and at night you run completely off PV. Maybe some peak loads gets covered from the grid. Another other option that the oaks do is they run big loads during the day when the sun is shining, so that also utilizes your PV quite a bit. It's pointless to have a solar system and you only at home at night and you're running all your high loads at night, so you're not going to save any power or any electricity costs that way. So it's better to optimize your loads to run during peak solar production, and then you're going to reduce the amount of power that you also have to take from your battery at night. And then other types of systems is with reduced loads, so there's not as many peak loads, and you can also have a smaller battery bank and smaller PV size, or PV system size, and that will cover this customer's requirements. So that's basically worked out on the amount of PV you produce during the day. That sum must cover your total consumption for the household for the day. And then the battery must cover at least 60% of the household's power, 60 to 70%. So that at night from 6 until 6 again the following morning, which is not going to be optimal. You're going to run from your batteries probably from about 4 o'clock in the afternoon till about 8 o'clock the next morning. So that's 16 hours. So that's going to be 70% of your loads is going to be mainly battery, or running from the battery. Depending on how you optimize your loads. So if you run more loads during the day, you can bring that down so that you only use maybe 30 or 50% of your load during nighttime. So if you size your system correctly, you can have it so that your excess PV gets stored in your battery, and your battery will feed your loads throughout the night. Following morning, you've still got sufficient capacity in the battery to take you through if you've got a little bit of overcast weather in the morning, and then recover the battery charge with solar if available. Next slide. So here's some examples. So this is a basic ESCOM connection. Then you've got a AC coupled PV system. That's just a normal grid type installation, saving power whenever there is electricity available to produce power. Next system we've got here is adding an energy meter to our grid type PV system and a backup system. So what we can achieve this way is feed in limitation on our compatible PV inverter, and also utilize some of that PV power to charge our batteries on the backup system. And we can also add critical loads onto our backup system. So that's computer, lights, fridge. So that's on a limited system. So the loads on top are fed directly from ESCOM, non-essentials, and then the critical loads are only fed from the battery when there's a power failure, or when you're running ESS and it's set to feed power from the battery. Now we can add a DC coupled PV onto the system. So that's just a normal Victron DC MPPT that charges your battery. So what this does is it charges to the battery bank directly, and your loads will be then fed from the Victron inverter, which inverts the PV power to your loads. But if you've got a system which is off-grid, or somewhere where there's big chance where the grids can go or fail for extensive periods, then it's recommended to definitely add a DC charging source onto your system, because that assists when there's a complete power failure on the system and your battery has drained beyond the disconnect point and ESCOM has failed for an extended period of time. Then your DC solar charger will immediately start charging the battery bank when there's PV available. Whereas your grid-tied inverter, whereas the grid-tied inverter is going to require an AC power source to recover and start producing power. So if your inverter is dead or your grid is dead, it's not going to start up to produce power and the system won't recover until the grid source is recovered.
Question. So, okay, this is the question because I've noticed, like, say you come to a scenario where there is no power for days at the site, some lines are stolen, and that battery is flat. I know on the SunSync you can leave the SunSync then on, and you can put the PV on, and that would get the battery back to its, like, start charging the battery. It's totally flat. But wouldn't that pop the MPPT if there is no, the battery is like beyond flat and there's no power?
Yeah, so if the BMS disconnects,
Yes.
yeah, you're still going to have a problem. So that's why you must program your system correctly so that it disconnects before the BMS switches off.
Yeah.
Because if your BMS switches off, you're going to have to apply a voltage source onto that. And the Victron MPPTs require a voltage source to start charging, so they're not going to be able to recover the battery. So that way you're going to have to get a generator on site, connect it on the input, and then switch the inverters on. It's going to be the only way to recover it that way. So yeah, it's very important to make sure that you set your disconnect voltages on the system, so that it doesn't drain the battery beyond the point where you can't switch on again. So the other type of system we can use is a standard DC coupled system, where we monitor our non-essential loads with a grid meter, and we've got our critical loads connected on the output of the Victron. And the Victron MPPT is supplying PV power to our non-essential loads if there is excess, and our critical loads as well as our battery. Other option we've got is just an AC coupled system. So these types of system is where you are going to struggle if there's an extended period of time of grid failure. If your battery is flat and it can't receive a charge, your inverter isn't going to switch on, and the inverter isn't going to switch on to start the Fronius inverter to start producing PV power. So in this state, you're going to have to get a generator out to site or wait for Eskom to recover the system. Other types of systems we can do is a no meter. So we're not monitoring any of our non-essential loads, or we don't have any non-essential loads on site, and we're running our critical loads from battery power and PV power. As well, we can also do that with AC coupled PV system and feed our critical loads from PV power and charge our battery from the PV power. Just note, if you don't have a compatible PV inverter that communicates with Victron and you are connected to the grid, any excess power is going to be pushed into the grid. So it's only the Fronius and ABB inverters that I know of that have the communication with Victron that prevents feed in while connected to the grid without any extra meters or anything. And then the optimal system, which I like the most, is an AC and DC coupled system. So this helps you if you've got any high loads during the day, that gets covered from your PV inverter directly, and your battery gets charged from your MPPT directly. So in the morning, optimal PV charge is reaching your battery, and optimal solar is reaching your loads from the AC PV inverter.
So just quickly, so that other The other PV you had by the grid, is that non-critical loads?
Yes. So if it's
That
connected
one.
there, yeah.
So
then
that's
it's just-
non-critical PV, then critical, and then DC.
Yes, so the blue line is non-critical, so it's going to be everything connected directly on ESCOM. So if you've maybe got a 5 kVA inverter and you want to supply your geyser with solar, but you don't want to supply
Yeah.
when there's a power failure, then you can connect your geyser onto the ESCOM directly still after the meter and have excess PV power from the DC bus or from the PV inverter feed your geyser.
And can you do all three, or is it just you have to choose two?
You can do all three, yeah. So you can have one on the input, output,
And DC.
and have a meter
Okay.
also just to monitor the non-essentials. Yeah, so you can have it like that, but you're going to require a meter to monitor the input unit as well.
Thanks.
So ESS system requirements, it's not good for any bad grids or off-grid systems due to the requirement of being connected to the grid for ESS system. If you want to run an off-grid system, it's better to do dedicated no AC, or just don't run any assistance. And when as soon as the grid connects, or there's a generator available, they will charge your battery source, feed your loads, and you can control that by other means with contactors on the inverter if need be. But yeah, ESS systems are made for grid-connected hybrid solutions. So not for systems that require the inverter priority or intentional islanding. So that's where you intentionally want to disconnect from the grid as well. So it's dedicated ignore AC, covers that functionality. Or need a multi-grid. Okay, so that's just on the grid connected, you're going to need a Multiplus II or anti-islanding device to connect onto the compliant grid if it's required. So the Multiplus II inverters or the Quattro 2 inverters have got the grid compliance built in, so they've got the dual contactor.